Okay, so like I said, if we're taking a look at limits, I'll take it if I have to. As I was talking about, when we're looking at limits, okay? Option number 1, can I do direct substitution on this one? Nope. Because if we plug in 0, we're going to get 1 divided by 0, which is no solution. It's undefined. Can't do that. Can we factor? Nope. That doesn't work. Okay. Can we do a conjugate? Probably not, right? So there's no square roots or there's nothing that signifies that, yeah, you should try a conjugate on this problem. So we've got an issue. So I'm going to go back to the graph for a second, and we're going to take a look at the graph, okay? Back to, this is a rational function. So with the horizontal asymptotes, vertical asymptotes, hole in the graph, all that stuff. So let's quickly sketch what this would look like. Let's put some axes down here. And let's start with, where would I have a horizontal asymptote? Okay, why is it y equals 0? Yeah, it's bottom heavy, so it's y equals 0. By the way, today is the day we're going to talk about why it's y equals 0 instead of just because. Okay, we'll get to that understanding. Where would I have, what values of x can we not have? 0, which means there's either a hole or a vertical asymptote. Which one is it? No hole, nothing canceling, okay? Vertical asymptote at x equals 0. Let's put that down. And now if you went through and you just kind of checked and sketched and all that kind of stuff, what I will tell you is the graph would look something like that. And then it's down here as well. Okay. All right, so we now have the graph, which means we should be able to answer the question. What's the limit as x approaches 0? Remember, when we look at a limit at a value, you got to check from both sides. Okay, so I'm actually going to come down to here for a second. If we're talking about the limit as x approaches 0 from the right side, the right-handed limit, that's what RH is standing for. What's the right-handed limit? Where is the graph going as we approach 0 from the right? It is going up to infinity. Okay, as we approach 0 from the right, you're going to positive infinity. That would be your right-handed limit. So I'm going to put positive infinity there. What about from the other side? What's the left-handed limit? Where's the graph going? As we approach coming from the left, the graph bends down to negative infinity. So those are the limits on each side, which means what's the limit at 0? Nope. Nope.
0.
Nope. Does not exist because the limit from each side is not approaching the same value. Okay, remember that's what you're checking. If the limit from each side approaches the same value, then that's the limit. If it doesn't, like we have here, then you don't have a limit. Okay, so the idea here is this limit does not exist because you're not approaching the same thing from each side. Reason why I started with this, 2 reasons. Number 1, when you look, I told you we're looking at like special circumstances here today, kind of. One of those is what's happening at a vertical asymptote. And what almost always happens is on one side, graph bends up to positive infinity, and on the other side, the graph bends down to negative infinity, meaning there is no limit at a vertical asymptote, okay, because of that. So if you identify a problem and you say, hey, there's a vertical asymptote at 5, you know, therefore, there's no limit at 5 then. Does that make sense? Okay, that's kind of something you can get from the vertical asymptote idea. The other thing that we're getting at is, I'm going to go to the next part. We're going to do the same problem, but let's take a look at, what if we changed what we're looking at? Instead of the limit approaching 0, now here we take a look at the infinity type limits. Okay? Let's say that the limit as x approaches infinity. And again, I'm going to start with the graph. What's the graph approaching as x goes to infinity? It's approaching 0. If you take a look, here's x going to infinity right there. The y values are getting closer and closer and closer to your horizontal asymptote. Okay? Which, by the way, is the main concept of today. When you go to infinity or negative infinity, notice the other side of the graph. If I went to negative infinity, what am I approaching? 0. The horizontal asymptote. When your x values goes to the two end of the graphs, infinity or negative infinity, you are approaching the horizontal asymptote, okay? Which means what's the limit of this? This limit is 0. And here's your explanation as to why, when we're bottom heavy, do we always have a horizontal asymptote at y equals 0? It's because of the limit. And here's what this is talking about. Here's the conceptual part. So we're going to take our equation, 1 over x, and I'm actually going to conceptually substitute in infinity. We're going to do direct substitution, except I don't have a number. I have infinity. So if we do that, 1 over infinity, I'm plugging it in. You need to think about infinity as just some gigantic number. What is 1 divided by some enormous number? It's basically nothing. As you're dividing by a bigger and bigger and bigger number, your y values are getting smaller and smaller and smaller and smaller. That's why the graph is approaching 0. That's why there's a horizontal asymptote. That's why there's the rule, if it's bottom heavy, y equals 0. Because when it's bottom heavy on the ends of the graph, your fraction is approaching 0. That's the idea. That's the reasoning behind it. Another way to think about it, by the way, let's say that's $1. And you're going to take $1 and you're going to split it between an infinite number of people. Each person is basically getting
way less than a cent.
Nothing. Each person you're not actually getting $0, but you're basically getting nothing. That's the concept of a limit. That's why that's the infinity limit is. We're spreading that amongst so many people. Everybody's basically getting nothing. Okay? So a little bit of background there. Let's go one more step. Here we go. Well, what if we change the equation to x plus 3 instead of just x? And you're going to hear me today say, we're going to kind of talk about each problem in two different ways. Conceptually, like the idea of plugging in infinity. And then you're also going to hear me talk a lot about horizontal asymptotes today. Because it's the same idea. So let's start with this. Notice the only thing I added was 3 to the denominator. Think about the same thing. Let's say I plugged in infinity. Okay, so let's say I did this. 1 over infinity plus 3. So now instead of dividing it by an infinite number of people, we add 3 to that. Does that 3 matter at all?
Not really.
No. When we're talking about stuff like the infinity or negative infinity, such gigantic numbers, that plus 3 means absolutely nothing in this problem. Which means what's the limit? 0. 1 over infinity is basically 0. Which again, I told you I'm going to talk about this from two perspectives. There's the conceptual side of things. You're still taking 1 divided by an enormous number, which is 0. Here's the other part. If you are looking at this equation, what's the horizontal asymptote? Y equals 0. Those are the exact same answers, okay? The horizontal asymptote is the limit as x goes to infinity, okay? They're the same thing. All right, let's keep going. Here is your number one. Make sure you write this down. Number one concept of today. Here it is right here. Let me get rid of that for a second. Write that down, and then I will explain, I'll interpret what that actually says. So I'm actually going to start at the bottom of this. Okay, I'm going to start down here. Here's what this says. If you find the limit of a function as x goes to infinity, okay, equals some number, let's say 5. Okay, I just called it b because it could be any number. So the limit as x goes to infinity equals something. Or the limit as x goes to negative infinity equals something. That number is your horizontal asymptote. Okay? So if you found the limit as x goes to infinity and it equals 5, that means you have a horizontal asymptote at y equals 5. If you found the limit as x goes to negative infinity was 2, that means you have a horizontal asymptote at y equals 2 because that's what's happening on the ends of the graph. They're approaching the horizontal asymptote. Your y values are approaching the asymptote. Okay? That is basically right there, I'm going to call that is your definition of a limit as x goes to infinity. Okay? That is your definition. So what does that mean in words? If you take the limit to infinity, the horizontal asymptote is the answer. Okay? Just like on those last two problems we just did, we said horizontal asymptote was y equals 0. That was also the limit as x went to infinity. Horizontal asymptote at y equals 0 because it's bottom heavy. Also, y equals our limit as x goes to infinity. Okay? So horizontal asymptotes and infinity limits are the same thing. Okay? You're doing the exact same thing. So that's basically the bottom part is explaining what the top part means. Okay? All right. Let me get into some examples so that now you can kind of get to that. One quick thing before we do examples, though. This is a reminder. We did this the other day. Remember I brought this up and I said, if you want to make you aware of this, it's going to come back. It's not the main idea right now. Well, now it's going to become very useful. I'm going to summarize this. You don't have to write any of this down. I'm going to summarize this entire page. All this says is if you are adding functions or subtracting functions, multiplying, dividing, raising a function to a power, multiplying it by something, you don't actually need to add the functions together first and then find the limit. This is saying find the limit of f of x, find the limit of g of x, and then add the two limits together. Do it as separate problems, okay? Or find the limit of f of x, find the limit of g of x, and then multiply those together. It's usually much simpler to find the limit of each part and add the limits than it is to try to do all the algebra. Okay, I'll show you that in a couple of examples. But that is basically what this is saying on this slide. Okay, all right, here we go. Now we're going to get into some examples. Just show you different scenarios just to make sure you're understanding how we find these. And this is the part I think you'll start to put it together and you'll start to appreciate how quick these actually are. Okay, there's not a lot of work to show on these. So if you take a look, here's one of those examples I was just talking about. You could go through and we could take that equation. We could try to find a common denominator and combine the 5 and the 1 over x and try to put that all together. But we don't need to. Instead, let's just find the limit of each part. Okay, let's just I can find the limit of 5, and I can find the limit of 1 over x, and then just add those limits together. What's the limit of 5? What's the limit of 5? It's 5. And here's how you get it. Think about the equation y equals 5. It's just a horizontal line. Every y value is 5. And remember, that's what we're talking about. So the limit of any constant is that number. Limit of 5 is 5, limit of 2 is 2, limit of 7 is 7. Doesn't really matter, okay? So that limit is 5 plus limit of 1 over x. Either think of it as, if I plug in infinity, 1 over infinity is basically 0. Or if you'd rather, when we're talking about limits to infinity, all we're talking about are horizontal asymptotes. What's the asymptote of 1 over x? It's bottom heavy. Therefore, the limit is the horizontal asymptote. And therefore, your answer to this problem is 5. There's the answer. Like I said, that is going to be a lot easier than trying to find a common denominator, trying to combine those, and then find the limit at the end. Okay, find the limit of each part. And that's it. You just showed all the work you need to show for that. Okay? All right, let's keep going. Let me give you another one kind of similar to that. What's that?
Is that x squared?
Yeah, x squared. Yep. 4 over x squared. Anybody tell me? What's the limit? 0. For 2 reasons. If you substitute in a negative infinity, here's what you really have. 4 over negative infinity squared. Now you don't just have infinity in the denominator, you've got infinity squared in the denominator, which means we're getting even closer to 0. Okay, you've got 4 divided by some enormous number, which means we're getting even closer to 0. Or if you prefer, what's the horizontal asymptote? Y equals 0, because it's bottom heavy. Again, same answer, okay, for 2 different reasons. So those problems both were bottom heavy. That's one thing we got to look at. Here's your next one. Okay. The limit as x goes to infinity of that function. Any ideas? What do you think the limit is? It's not 1. I'll give you two hints. You can either think of it as going to infinity, which actually in this one's a little bit more difficult, or think about the horizontal asymptote, because the answer is the same either way. What is it? Not negative 1/2, negative. Let me get you there. Here we go. First question, when we're talking about infinity, does that 1 matter? No. In the big scheme of things, 1 has no effect on infinity. Okay? Ignore. Does this 1 matter? Nope, for the same reason. Ignore. Okay? Which means what you're really looking at is this right here. Remember top heavy, bottom heavy versus tie? Isn't this a tie? Yeah. Where's the horizontal asymptote? At negative 5/2, which means that's the limit. Okay? That is the limit. This is a tie, and therefore you use the coefficients. Okay? Negative 5/2 is your limit. So like I said, we did a couple of examples that were bottom heavy to show you the y equals 0. There's an example where it's a tie, which means we're just using the coefficients. Okay? And we've got one option left. What haven't we looked at yet? Top heavy. This one's gonna suck.
Hey, I don't want to hear that graded. Slant asymptote. I want to hear the encouragement.
It's not as bad as when we had to do slant asymptotes before. I promise. It's not gonna suck as much as you think it is.
Give some hope to the children out there. What are you talking about? This one. Just reading life.
Okay, first question. We're looking at as y approaches infinity, which means, does the plus 1 in the denominator matter?
Nah.
Nope. All we care about when we're talking about infinity are the highest degree terms. That's how we found the horizontal asymptotes on that orange sheet. You always looked at the highest degree. So the plus 1 doesn't matter. Now, what's happening when it's top heavy? I think Braden said it before. We have slant asymptotes, which means, here's what's going on. If you have a slant asymptote, let's say it's a slant asymptote with a positive slope, that means the graph is following that slant asymptote either to infinity, or if the slant asymptote is negative, it's going to follow it to negative infinity. Your answer is, with slant asymptotes, is always one of the two. Positive infinity or negative infinity, depending on the slant asymptote. Does that make sense, by the way?
Yeah.
Here's a visual if it doesn't. there's a positive slant asymptote and there would be some graph, there it goes, following it to positive infinity, okay? If the diagonal was going the other way, then it would go to negative infinity. So we know it's one of those two answers, positive or negative infinity. The question is which one, and here's what I think is the easiest way to find it. If you go back to your highest degree terms, let's say we simplify that. What does that simplify to? Do some canceling. Yeah, the y squared on the bottom, cancel out 2 of the y's on the top. So that would simplify to 4y squared. Thank you. Yep. Now, all I need to figure out is it positive infinity or negative infinity? Think about taking positive infinity and plugging it in. If I take 4 times infinity squared, am I going to get a positive answer or a negative answer?
Positive answer.
Doesn't matter whether it's infinity or not. If it's squared, it's positive. Times another positive number, we are going to get positive infinity. There is your limit. Okay? The only real thing you have to figure out with slant asymptotes is it going to positive infinity or is it going to negative infinity? And like I said, that comes from simplifying the highest degree terms and then substituting in your either infinity or negative infinity. Question, by the way, if we were talking about negative infinity, let's say that this was plugged in for negative infinity, what would the answer be? Would it still be positive or would it be negative?
Positive.
It's still positive. So even if x was approaching negative infinity, when you plugged it in to the end, you still would get a positive answer, okay? So it's still the same idea, just as a heads up. Okay, last one. I've got one more to go.
Got 3 minutes to get back. Hurry.
Perfect. I won't even need it.
Oh, awesome.
Here we go. There's last problem. Put it all together here. So you have 2 things to think about as you look at this. And one is hopefully way more obvious and you'll get to it than the other, okay? What I mean by that is I could go through and try to work on all of this algebra and get a common denominator and try to combine it and then find the limit. Is that a good idea? No. That would not be a simple task. That would not be good, right? You can do it. It's not impossible, but not a great idea. That's why there was that slide that talked about all those properties of limits. Instead of having to do that, let's just find the limit of each part and we'll add them together. Okay? What's the limit of that fraction as x goes to infinity? 1/2. Why is it 1/2? Because the plus 1 doesn't matter at all, and you've got a tie. Horizontal asymptotes at y equal 1/2. That's why it's 1/2. When we go to the other part, I'm going to bring the plus sign down here. We're going to add the 2 limits. Any ideas? It is 3. Here's why. Remember, if you can either think in your head or actually do it. If I squared out the x minus 3, you are going to get x squared minus 6x plus 9 if you squared that out. Okay, so let's say I ignore that. Now, top heavy, bottom heavy are the same.
The same.
3x squared and an x squared. It is 3.
Then you add the 1/2 and 3 together.
Yeah, look at you go. There's your second limit right there, which means your answer is 3.5.
Bro, really, what happened?
There's your limit.
I have the answer in the box.
How we doing?
Just fantabulous, baby.
Okay. Like I said, notice there's not a whole lot of work here. That's why I said even with the 20 minutes that you have,
You got 21 actually.
you have, see, 21. I gave you a bonus minute.
Oh.
Okay?
Bonus minute.
Now, you're going to freak out when you see the assignment, okay? But you shouldn't freak out because you're going to look at the number of problems and start to freak, and you don't need to freak out about it. Yes, there's 34 questions on this assignment, which will take you about 10 minutes, okay? Or maybe
Can you
15.
give us odds or no?
So, no odds. All. We're doing all today.
Yeah, Biggie, can we play Oppenheimer?
No.
No, play the playlist. It's like, it's
Oh.
just soothing music. It's just
I gotcha.
soothing music.
Thought you meant play the movie. No, I'm not playing Oppenheimer. No, I will not. But I can play the music, sure.
I'm sure like Cooper Hinn or watching on the computer or something, but.
Quick heads up on the worksheet that I just gave you. The first set of problems, you've got all of these graphs. What you are trying to do is match up the graph to the equation down below. Okay? What I would suggest you do to make this as easy as possible, take your equation, whatever equation it is, find your vertical and horizontal asymptotes, and then look at the graph and see which one matches your vertical and horizontal asymptotes. Okay? So take the equations, and notice on number 4, this will help you, by the way. If you take what is given, and let's say you actually found a common denominator and put it together, this is what you would actually get. I would say number 4, it's easier to look at that equation than it is to look at the one that's separated. Okay? Which is why I put it there. When you get to number 9, then the rest of the worksheet is like what we were doing in the examples. Okay? But the first 8 here are matching. Find the vertical asymptote and horizontal asymptote and match it to the equation, or match it to the graph, excuse me. Answers are on the back. Okay? Let's go to work.